Okay, Bismillah ar-Rahman ar-Rahim. Welcome to A-Level Maths live lesson. Today's topic is algebraic fractions. Okay, let's take a very simple fraction, which is 5/8. And let me just write a couple of fractions that are equivalent. That means they're the same. If you were to type them into a calculator or you were to change them to a percentage, you'd get the same percentage. So 5/8 we could have 10/16. We could have 50/80. We could have 5x/8x. So all of these fractions are equivalent to the original 5/8. And the question is why? Why do we say that they're equivalent? Why is it that when I work out 10/16 I get the same answer as 5/8? The fraction looks different, but how come it doesn't give me a different answer? And you might say that, well, I've times the top by the same number and times the bottom by the same number. But let's just take a look at that in a bit more detail. What I've really done is take advantage of any number you could think of. Let's just say, pick a number 7. Any number, if I multiply that by 1, it will never change. I'll always just get the same number I started with. So 7 times 1 is 7, 0.6 times 1, it would still stay as 0.6. And the same applies to fractions, because fractions are really a number. So 5/8, 5/8. If I'm just timesing that by 1, then it's still going to stay as 5/8. The answer is not going to change. But then let's look at the number 1. I can rewrite 1 as any number divided by itself. So for example, 1 divided by 1 is 1. 2 divided by 2 is still 1. So if I wanted to, instead of writing 1 there, I could have written 2 divided by 2, because it's just 1 in disguise. 2 divided by 2 is 1. So really, if I write 1 or if I write 2 divided by 2, it's the same thing. It's really just 1. So 7 times 1, or 2 divided by 2, is just going to stay as 7. What about this one here? I could write 1 as anything I like. I could write, as long as it's the same number divided by the same number. So if I wanted to, I could write it as x/x, or I could write it as 100/100. But it's just 1 in disguise. And then similarly, what about this one here? I could rewrite that as something divided by itself. Now, to get the 10/16, if I rewrite 1 as 2 divided by 2, 2 divided by 2, no one will ever argue, that's just 1. So when I'm timesing by 2 divided by 2, I'm just timesing by 1. So 5 times 2, that's 10. 8 times 2 is 16. So that's why 10/16 is really the same as 5/8, because the starting number hasn't changed. It will never change if all I'm doing is timesing by 1, which is this bit here. So how does that help you with algebraic fractions? it means that you can have any fraction, and as long as you're timesing it by 1, then it doesn't really matter. So you could have, let's say, 5y over 3. And it's a fraction, it's a number. It's just that I don't know what the y is, but it's still a number. So if I times that by 1, it will stay as 5y over 3. If I times it by 1 written as 2 over 2, then it will still be 5y over 3. It will still be the same fraction. So in this case, let me times it by 2 over 2. And then what I'll have is, instead of 5y over 3, I'll have 10y over 6. It's a fraction that looks different, but apart from looking different, I know it's exactly the same as what I had originally. It's still the same as 5y over 3. Let's try it the other way around. Let's say I had a fraction 3 over 2y. I could times that by 1. It would stay the same. And that 1 can be written as anything I like. I could write that as 3 over 3, for example. And that would allow me to change 3 over 2y into 9 over 6y. Has the fraction changed? No, it just looks different, but it's really the same fraction. I've times by 1, timesing by 1 never changes a number. So it's just a number that I had at the beginning, and it's the same number, it just looks different. So now when it comes to adding fractions, particularly algebra ones, so let's say I had 5 over 2y plus 6 over 8y. So here I can't just go ahead and add the tops and the top and get the new answer, because the bottom, called the denominator of the fraction, is different. 2y is different to 8y. So I need to make the denominator the same if I'm going to add these. And what I look at is I say, well, 2y, I can make that, if I times this fraction by 1, it will still stay the same fraction. But what if I times it by, instead of 1, let me times it by 1 in disguise using 4 over 4. If I times by 4 over 4, that's really timesing by 1, so it won't change the number in the question, it won't change the fraction in the question, it will still stay the same size. But the advantage is that I won't have 2y on the bottom anymore. So let's try that. Let's take this first fraction and times it by 4 over 4, and then what I'll have, if I times it by 4 over 4, I will get, and I'll just make a note on the side what I'm timesing by. So I'm timesing by 4 over 4. 4 over 4 of course is 1. Timesing by 1 doesn't change anything. You can times whichever number you like by 1 and it will stay the same. So the top will become 20. The bottom will become 8y. Have I changed the question? No, it's the same question. It just looks different. But the advantage is that now I've got 8y on the bottom, which matches what I have at the bottom of the second fraction. So now I can go ahead and add the top. 20 plus 6 is 26. over 8y. And you can use that technique as long as you can spot an easy thing to multiply by, which can be written as 1, and it will make the denominators match. You're trying to make the denominators match. So let's try 3 now. 3 fractions. We've got 6 over, let's say, 5y. Let's go 5 over 6y, and 7 over 18y, and 5 over 12y. So you're looking at these 3 fractions. I want to add them all together. The problem is the denominators are different. So I look carefully. I've got 6y, 18y, 12y. I'm going to have to change a couple of them so that I get the same denominator at the bottom. Easiest thing to do here is let's choose 18y, which is the biggest number, and make all the others match the 18y. So the first one, which has got 6y, I want to times that by 2 over 2. And that won't be enough. It's got to be 3 over 3, and that'll make 18y on the bottom. I can leave the second one as it is. What about the third one? I need to try and make it 18y. Might have a problem here. What I could do is times by 1.5. I could divide by 2, times by 3. But let's times by 1.5, so 1.5 over 1.5. If we get decimals in the fraction, at GCSE was a bit of a problem. Here we can handle it. Try to avoid decimals if you can, but it's probably the easiest thing to do, just to use decimals here. So let's work out what the new fractions are going to be. I've got the first one is going to change from 5 over 6y timesing 3 over 3, that would mean 15 over 18y. The second one's going to stay as it is, and the third one I'm going to times by 1.5 times by 1.5, so that's going to be 7.5 at the top, 18y on the bottom. And the second one in the middle here, that's just going to stay as it is. And the denominators all match up, which is fantastic, and I'm ready to go. So that's on the top 15 plus the 7.5 plus the 7, that will make 29.5. On the bottom, 18y, it all matches, so I can just write 18y. Okay, not too happy with the decimal, but it's fine, you can get away with that. If you wanted to, you could double this, and that would be 58 over 36y, but I'm just going to leave it as that, that's fine for now. Okay, one for you to try. Give you an easier one and then a harder one. Let's go with 5 over 7y plus 8 over 21y. And on the bottom, just have a go at that first. And when you're ready, please type the answer into the chat box. Just to make sure you've got the basic concept. That brown one is easy for you, then have a go at the green one as well. Slightly harder, but it's the exact same concept. Okay, perfect on the second one. Well done to Aisha. 33 is the correct answer at the top. Just to explain how you do that, the denominator here is x plus 2. We need it to be 2 times x plus 2. So we're just going to multiply this fraction by 2 over 2. And that means we're going to have 18 at the top. Add the 15 makes 33. And the denominator will be 2 and x plus 2. 2 times x plus 2. Just a few more seconds to do the first one. Okay, very good again, mashallah. First one, the first fraction, we need to change from 7y to 21y. Easiest way is to times by 3 over 3. That'll change this first fraction. At the top we'll get 15, at the bottom 21y, and we will end up with 15 plus the 8 is 23 on the top, and 21y on the bottom. Okay, good. Hopefully that was a gentle introduction to algebraic fractions, and in the next lesson tomorrow we'll try to work on some harder versions of this. Join me tomorrow, same time at 9 p.m. inshallah, if God wills. Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be with you and the blessings of God.